Okay, so for this one, the marketing department of the company has determined that if it spends X thousand dollars on radio advertisement and Y $1,000 on newspaper advertisements, the company's revenue in thousands of dollars will be this equation. How much money should the company spend on radio advertisements and newspaper advertisements to maximize revenue? Okay, so since we're trying to maximize something, what we're going to want to do is use our second derivative test and look for a maximum. So remember, the first thing we do is we find our critical points, and then we compute all of our derivatives, our second derivatives, find D, and then use that to determine where the maximum is going to be. So first off, I find our critical points. So for that, I need the first derivatives. So I'm going to do R of X, and that will be, bring this down, so negative 0.12x. That term drops out because it's a y. That will be a plus 6 right there. X to the first. That term drops out because there's no x. And then that would leave us at 3y. And then we'll do the same thing. We'll take the derivative with respect to y. So here, that's going to be negative 150y. And then the x terms drop out, so this will be a plus 3. And then that's going to be a 3x. So then remember, to find our critical points, what we have to do is set each of these to 0. So I'll write that over here and come back. So this time we have a system of equations. We have both x's and y's in each equation. So what I want to do is get this kind of in standard form. So I'm going to bring the constants over to this side and then solve the system. So I will rewrite this again now in order with these on that side. Okay, I realized as I was writing that out, I wrote 3x instead of 3y right there when I copied it over. So now I have it, something x plus something y equals the number. So we're standard form for solving an equation or a system of equations. And so what I'm going to do next is figure out, don't want to do the decimal, that just doesn't sound that fun. So I'm going to eliminate y. I'm going to multiply this one by 50 on both sides. And then that's going to get me plus 150 minus 150. And let's see, so that's going to look like 50 times that comes out to negative 6x. And then times here gets me plus 150. And then 50 times there is negative 300. And then just rewrite this equation. And now I can use elimination to solve. So we get a negative 3x on this side. Those drop out. And this is negative 303. And then dividing, looks like x is going to be 101. And so now to solve for the second half of that, the y, I'm just going to take this, plug it back into an equation, and then solve for the y value. And that one right there looks pretty easy, so I think I'll pick that. So I'm going to go 3 times 101 minus 150y equals negative 3. So this will be 303, 150y, and then adding that over, or subtracting that over actually, that will be negative 306. You really wanted that to be 300. And then dividing, oops, we get this kind of ugly number for y, and that is 2.04. But remember, these are in thousands, so we're really, when we're going to put the answers in, we're going to have to move the decimal place, because it's going to ask, I think, in the question for actual dollars, not in thousands of dollars. But I'll get to that after I do the remaining piece. Okay, so all of that was just finding the critical point. So now we're going to find our second derivatives and use that to verify that this is actually a local maximum and not a local minimum, because that would be a bummer. And then that will determine our answer. So let's find our partials. So coming back here, there's our R of X. So that is going to go, that's like a little 1, so we take our derivative, and that's going to be negative 0.12. And then for y, take our derivative, these drop out, that's our 1, so that's going to be negative 150. And then x with respect to y, so this would drop out, this would drop out, and this would be a 3. And we should get the same thing, y, and then x. And yes, we do. So this drops out, and then that leaves our 3 right there. So the number we're doing back here is this. So this would look like our D is negative 0.12, 150, and then minus 3 times 3. And we do out that math. What did I get when I did it? 18 minus 9, or D equals 9. So, okay, so D is greater than 0, so that means we do have a local min or max. And then remember, then we go back to the double X one. The sign on that's negative, so that's less than 0. So it is indeed a maximum, not a minimum. So that means that point that we found back here is correct. And it is going to be a maximum. So remember our X was 101, but this is in thousands. So that's 100,000, 101,000. And then our Y was 2.04. So moving that 3 places, Y is $2,040.